I believe aerogel will be a material that will be used in the 21st century almost as much as plastic is being used today. Can you imagine your world without plastic? Well, aerogel will be one of the most used material in everyday applications in the 21st century. It is extraordinary by the scope of its properties. It can be an excellent insulator, both against heat and cold, so it's a thermal insulator. It's an acoustic insulator. It dampens out noise. Actually, as much as 80% of noise can be stopped by a piece of aerogel. It can be an electrical insulator as well. It can be also an electrical storage unit. You can actually use it to store electrical energy. I can describe aerogel like a fine mesh of silica particles, the same material that makes sand or we make glass out of, connected together in a maze of strands, each one 100 times smaller than a fine hair. And in between those strands is air. This amazing solid is actually comprised of 95 to 99% of air, only a few percent of solid. Unfortunately, a few imperfections in the microstructure of the material ruin the transparency we're trying to achieve. You can picture what is inside the material as billions of small cavities, each one of them as small as 1,000 times smaller than a grain of sand. 1 out of 100 of those cavities is just a little bigger, and it is big enough to actually interact with the light that comes through the material and scatter it. When it scatters it, just like molecules in the sky, in the atmosphere, scatters blue light, it affects the transparency of the material. So what we want to achieve is actually to try to control the emergence of those bigger cavities. And gravity may be a factor.
It's only 3 times denser than air, 3 times heavier than air. So we're almost close to a free-floating solid in that case. A block the size of a human of aerogel would weigh 1 pound. So you can imagine it's pretty extreme weight loss in that case. From our rocket flight in April, we saw anywhere from 2 to 5 times improved control over pore structure. And what that translates into is several orders of magnitude reduction in light scattering. So just based on a 7-minute rocket flight, I think we're looking at orders of magnitude change in the material properties. And so the idea is to duplicate that on a large scale on the shuttle or space station. The particular focus for NASA on aerogels is simply to create a more uniform pore structure. In other words, we want a defect-free aerogel. And there's a lot of hints, both from a rocket flight we had in April and ground experiments, that gravity is the key to understanding why those defects form. So in that case, we're going to get we're looking at a transparent aerogel as one of the primary aims of this program.
Well, NASA's getting involved in aerogel research because we bring a unique environment to the table. Scientists have already looked at a lot of process variations, how they can mix the chemicals in different amounts, or changing pressure and temperature and other sorts of things that a normal scientist would do in a laboratory to get a better outcome of a gel. What we bring to the table is the ability to go to weightlessness. And with this weightlessness, we believe that we'll get a much more uniform pore distribution, which could translate to a much more transparent aerogel. NASA is well known for exploring the planets and the stars and the origin of the universe. But what I'm excited about is using space research on products like aerogel that can have a major impact on people's lives here on Earth.